more people joining after 10 minutes. I think it's not a good practice to get this late. 10 minutes is kind of too late. So maybe next time just try to get here on time. I understand that most of you are teachers who expect your students to arrive and get in the class in time. So just do the same for this particular course, because we are letting so many others wait for us to join. I don't want you missing from the main content discussions. In any case, last week we covered this third table. The third table is about the Python environments and options. And we said that just you have three different options. The first option is using your own local environment. To use your own local environment, you can use your laptop and set up with Anaconda, whether like the full version or the minimized version of Anaconda. Or the other option in relation to Anaconda is to use Anaconda's cloud environment. But for the local environment, you have to download the Anaconda installer, install it with a corresponding Python, Jupyter executor, Jupyter Notebook executor. So for that, I said you can go through this link, which is the second link in the first row. And this second link is Harvard University's wiki. The Harvard University created this wiki for its students, so I didn't want to recreate while such a great school had put the details and brief instructions of each of the areas that you should know. Now, the second option that we had was using Anaconda Nucleus, which is Anaconda Cloud environment. You have to create Anaconda Cloud account, and you can access the Anaconda Nucleus or the cloud environment which is available. And the third option is using Google Collaborator. The Google Collaborator requires you to have a Google account and set it up properly. Then just you can quickly use. And the fourth option we have is using Microsoft's code space. And that requires you to sign up for a GitHub account. And once you have GitHub account, mainly like in these three cloud environment settings, you would need to have their corresponding account. The purpose of you having an account is to protect your code. Your code is going to be stored in a cloud file storage location, or in the case of GitHub, it's going to be stored in a repository, and then from there you can execute your code on the corresponding virtual machine that's provided just solely for you for a given moment. After a certain time, the cloud environment will be taken away. The virtual machine will be taken away once you are out of that session, so that it can be used by other users. These all three are free services and don't require any settings. So these are the things that we discussed. And going forward, here is how I am sharing. So these two tables will remain the same. The table 2, the second table, and the third table will remain the same whenever I share. And what I'm going to do is, for example, the week 1 recording is here, week 2 recording is here, and week 3 recording is going to be appended at the top and then this new label is going to get changed. So the new is going to be for week 3 new. So in descending order, you will see the top is going to be the latest recording. So this table 1, is continuously changed as we add more recordings, as we discuss more things. This table will have the recording link with the corresponding password for each week, but at the top. So just for your information, this enables you to access the recordings without going through multiple emails. So I'm going to append the recordings at the top, the latest recordings at the top, and then we'll resend this email every time I share the recordings. So this is basically to help you save time by avoiding searching through your emails, trying to find where the latest recordings are, where these two tables are also important. The second table is where you can find the reference books and code. The third table is the cloud environment setup. So this is what we covered last week, and we will continue. In the last maybe 20-30 minutes, I will be explaining about the project that I said I'm going to share with you so that you can work in teams and then share or practically experience the machine learning process in phases. So I will explain that detail maybe in the last 30 minutes. So let's go ahead and discuss about the code that we started discussing last week. So as we said, now I'm currently using my local environment. Of the 4 options, the 4 options are using your local environment, or using the Anaconda cloud environment, or using the Google Collaborator cloud environment, or using the 4th one is using the Microsoft Code Space, which is provided with GitHub. So these are the 4 options. I'm using the first option, which is using the local environment. So last week we started discussing about Pandas, and Pandas are among the important libraries, Python libraries that enable you to effectively do machine learning processes. And so to go through for data analysis, we said we need to have data, and the data has to be transformed to a desired format, and it should be cleaned, and we have to prepare or train a model, and then just analyze trends and make decisions. So this is the entire process. NumPy is, as we said, the Python library, which has a multi-dimensional array, or like the capability of containing data, having a multi-dimensional array, and with methods for processing arrays. So it's a library, and it enables you to do element by element operations, plus mathematical operations like logical, Fourier transform, shape manipulation, linear algebra, and random number generations are possible using the Pandas library. And the way you want to check the availability of Pandas Pandas library on your environment, once you set up, you have to install the libraries. So once you have set up your environment, to check whether or not just you have a Pandas, a NumPy library, you can simply just say import, which means try to bring the library as this is alias, like a nickname of the library. Instead of using the library as is, which is a long name, we are using a short nickname or called alias. So using this alias, we try to get the version, and let's run it. So just you click display, and then just it runs. So my environment, my local machine has got the 1.0 to 0.3 environment. We discussed about that. And if this fails, for example, like let me add A, this library, such a library doesn't exist, and then let's run. And when I run, this basically throws exception, saying that no module named NumPy A, because I updated, like I gave it a wrong name. So you would get when with a known name like NumPy A, quote unquote NumPy A, if you don't have the module on your environment, then it tells you that your environment doesn't have or no module named NumPy A. So you can fix it by using this instruction, percent pipe install. So this percent is required if you are executing this command from a Jupyter notebook, from a notebook. This percent is not required if you are running the pipe install in the library name. The approach is the way you install is pipe install, then the name of the library name. Library. Okay. Library name. Then just this is how you do it. And this is on a command line. But you add percent is percent percent is for Jupyter Notebook. Okay, so for Jupyter Notebook, we need, and then just if you say this library doesn't, or this module doesn't exist, you install this. And then just we went through some of these details, and we were able to create array, and then just we printed this. And also we can have a two-dimensional array, which is 1, 2, and 3, 4. These are two-dimensional array. And then just if you see the shape method, B is the name of the array, and shape is the method on this object, the array object. Shape will give us the 2 by 2, a two-dimensional by two-dimensional. Let's say I add 3 here, and what would we get? Run, and then just it shows visible deprecation, creating an array from rigged nested sequence. So it's saying that just the sequence is the two sequences don't match. And what does this give us? The shape, and you see what the shape comes back. So you see, it knows it has got 2, but the other dimension, one is a 3-element array, the other is a 2-element array, so it got confused. So this array is not right. So just we have to add 5 and it's taking some time. Okay. Can you hear me? Give me a signal. Okay. Okay, good. I think you can hear me. So this array is now I made it equal. Then just the deprecation message should go away, and it should print a 2 by 3 array, and then the shape should show me its corresponding shape, what the shape is, like two arrays, each having 3 elements, and then we can also create n-dimensional array by wrapping a list. So this is a list, and then just array can be created from list. I believe we covered this. I will be fast on this. And again, we can create an array of numbers of a specified range between 10 and 100. As you can see, 100 is not included at the end, but 10 is included at the beginning. So the array will be a one-dimensional array with this. Now, we can also create a 5 by 5 array of zeros. 5 by 5, as you can see, the second number is 6, but 6 usually is not included, like just the last cutoff point is not included, as you noticed earlier here. And then just all the matrix, the 5 by 5 matrix, is going to contain all zeros. The reason is because we said we need zeros. So NumPy enables us to create arrays. It also enables us to manipulate arrays. The other option is creating a linearly spaced vector with spacing. So here we have numbers between 0 and 20. In this case, 20 is included, but the distance between each consecutive numbers is 5. The last parameter is about the distance between the numbers, and the first and and the second parameters in the line space are the beginning and the ending numbers. So 0, 5, 10, 15, and then 20. What happens if we say this 6? If we say 6, then let's see. It should stop at 18 because it cannot pass the 20 mark, right? Oh, okay. So 20 got included, but well, 0, 4. Oh, okay. Okay, yeah, that's the reason why. And the start, the stop, and the step. Okay, so it is dividing the numbers into. Oh, okay. So that was wrong. The step means how many spaces do we want? How many spaces do we want? 7 spaces, right? Or 7 elements. 0, 1, 2, 3, 4, 5, 6, which means excluding 1, 6 elements. So this is how you would be creating arrays. I hope you went through this file because I shared you the details. And I will move on to the next section, which is indexing of NumPy arrays. NumPy arrays can be indexed. For example, the array is created as a range from 2 and 20. So the array is equal to just, you can simply print the target array by writing it. So this is initialized as a range of numbers between 2 and 20. And what we're doing here is accessing the 6 elements. Elements 0, 1, 2, 3, 4, 5, and 6. The sixth element is 8, because indexing in Python starts from 0. 0, 1, 2, 3, 4, 5, and then 6, which means the seventh element. The seventh element, if you count from 1. The first, the second, the third, the fourth, the fifth, the sixth, the seventh element, because indexing starts from 0. Or you can start from 0 and then just 0, 1, 2, you get to the seventh element. So this is how you can access an element from an array, in an NumPy array. Okay, let's go down. And here, Python's concepts of list slicing is extended to NumPy. The slice object is constructed by stop and step parameters to slice. So the array is arrange 20, and then just you can see, and then the array slice is slice 1, 10, 2. The start, the stop, and the step. And the element 2 is the array 6 of the 6th element of array 6. And now let's print and see what happens here. We can actually add and we could close some of the apps that are making my environment busy. Right, I'm going to add what array 6 is. And so let's rerun this. And so the array 6, which is this element, is arrange 20. That means you start, if you are simply providing one element, you start from 0 and then just this value -1, which is 19. 20 minus 1 is 19, and it starts from 0. And then what we did is here slice from 1 to 10 in a space of 2, right? Then here we go. The slice is defined as the start number and the stop number in the step. The step is you go by 2, you increment by 2, then 1, and then you step by 2, 3, you step by 2, 5, and 7, 9. Since 10, although 10 was supposed to be the stop number, but if we increase from 9 by 2 step, it will be 11, which is outside of the stop sign. So this is how you can slice numbers. Slice items beginning with a specified index. Now, another way of slicing in Python is providing the beginning index. The beginning index is in Python is like this. So this is just from index 2 all the way wherever it is, or here this means from the beginning to 15, but here from 2 to the end. So if the colon comes after an index, that means you start from the index and you go wherever the array ends. If the colon comes before the index, then you take everything from the beginning all the way until the specified index. So let's run this and see what happens. You know, this array 7, which is range 20, is exactly that as array 6. So array 6 is printed as 0 through 19. Yes, 0 through 19. But the index 2 of the array, index 2 of this array, which was exactly the same as that, in the array 6, it means 0, 1, 2. 0 is the number, the index, the starting index, and then 1, and then 2. 0, 1, 2. So you start from here. You start from here all the way to the end. So the end is here. So you get this array when you print, because this is in slicing, index slicing. You will see this kind of applications wherever we try to manipulate data for machine learning data pre-processing. The reason why we're discussing about NumPy, Pandas, and also data frame is because it's very important to understand the Python concepts. Otherwise, you would see this and then just you get confused, right? So you would see such slicing or cutting arrays, then you would get confused. And the other, so here, this, as I said earlier, is you start from the beginning of the given array and then you stop at this. So in general, so when you are given with such, let's say, n, then start from the beginning of the array from index 0 of the array, like from index 0 of the array and stop or end at index n of the array. So this is what that means. But the previous one means here, and the number is before the column, the index is before the column. Then this means start from index n of the array and stop or end at the last index, at the last index of the array, not, okay, so the last index of the array. So this is important. These concepts are important. And there are others. For example, here, now we were dealing with only one-dimensional array. We can have a two-dimensional array, which involves, for example, like just here we have 1, 2, 3-dimensional array. A 3-dimensional array, each element containing 3 elements. So the shape of this array is 3 by 3. I will quickly show you. And I'm running it, but let me add a code here. D is the array name, shape, then the shape of the array is 3 by 3. It's running. You will see. This is 3 by 3 array because we have 1 array, 2 array, and 3 array, each containing. The first number shows how many of this type of element. The second number shows, or dimension shows, the number of elements in each array. And then the arrays could be n by n or n by m. So we are simply this is a two-dimensional array. It could be a three-dimensional array. I can have this added here and right. So this is one array, and I can have another array by simply adding it. So now I made it. So if I execute this, it is executing. Okay. Failed elements must be 2 or 3 tuple got 1, 2, 3. Okay. I think I made something wrong here. It's not complicated anyways. Let's run it, this 2 by 3 by 3 array is fine. And yeah, I was supposed to give it another brace then. In any case, so this means slice the first 2 rows and the first 2 columns. The first 2 rows and the first 2 columns. If we write D without the slicing, D would look like this. D looks like this. I'm running it, and then just you will see D. So before the slicing, this is the slice result. This is the slicing, and the full view of D is 1, 2, 3, 3, 4, 5, 4, 5, 6, and the 0 to 2, the first 2 rows, and then the first 2 columns. So we are slicing horizontally and then stopping these, the first 2 rows, and then vertically we are slicing. Once we slice the first 2 rows, then just we are again slicing the first 2 columns. Out of the 1, 2, 3, and 3, 4, 5, we are slicing 1, 3, and 2, 4. So this is what the slicing means. Going further, shape returns a tuple consisting of array dimensions, and the attributes returns the number of array dimensions. So earlier we can write and like let's run for this array D. D returns the shape 3 by 3. And okay, because we didn't D is failing for the second part. So then so D shape returns the tuple consisting of the dimensions, and D n dimension returns the number of array dimensions. We have 2 dimensions, 2 dimensions, 1 dimension here and the second. So just simply that a 2 dimension. But this, the first one tells us the size of the tuple, the dimensions in the respective detail. And 4 is the item size, returns the length of each element of array in bytes. So and now here we have we want to create a NumPy array with empty having 3 by 2 dimensions with type integer, and then just the printout of this looks like this. We are initializing an initialized array of a specified shape and type, the specified shape and type. So it is a 3 by 2 1, 2, and then 3. The data type is, as you can see here, here. And zeros, as we said earlier, returns a one-dimensional array of 0 elements. Now this is about the NumPy. So if you remember our discussion last week, I asked you to go through this note, especially chapter 2. Chapter 2 talks about understanding Python. This is the Python handbook chapters. So about NumPy, chapter 2 is dedicated for NumPy. Chapter 2 is dedicated for NumPy. And chapter 3 is dedicated for Pandas. Now we summarized, there is so much detail about NumPy, which we briefly discussed and then just summarized, but go through the details of this chapter if you haven't already, and then just you can learn more, because that's going to be what we are going to use for our machine learning process. In the third chapter of the Python data science handbook is about NumPy, which is about Pandas, which we are going to cover now. Okay, going back to our notebook. So Pandas, and just like NumPy, which is a Python library that enables us to handle process arrays, Pandas is a Python library. It's an open source Python library providing efficient, easy to use data structure and data analysis tools. The name Pandas is derived from panel data, which is an econometrics from a multi-dimensional data. Pandas is a well-suited for many different kinds of data. Pandas can contain a tabular data with heterogeneously typed columns, ordered and unordered time series data, arbitrary matrix data with row and column labels, and any other form of observational or statistical data sets. So the data actually need not to be labeled at all to be placed into a Pandas data structure. And we will see some examples. And Pandas provides 3 data structures, all of which are built on top of the NumPy array. All the data structure are value mutable. Pandas is built using NumPy. So when you use Panda, behind the scene, NumPy is used in this library. And the way to use Pandas is by importing it, this library. And by default, usually like just NumPy and Pandas sometimes get installed, but you have to double check their availability. And as we did earlier, PD and then dot version is the IntelliSense is loading. Version, and then let's run. This is double underscore, and so let's see what version of Pandas I have. Panda, when you import Panda, the most common alias that's used is PD, as was in NumPy, NP. NumPy was imported as with an alias named as NP. Pandas is imported as using PD. Now, a series is a single dimensional array structure that stores homogeneous data, that is data of a single type. Homogeneous data means if you have integer in a series, if you have the first element of the series as integer. All the rest of the elements in that series are integers. If you have string in the first element or wherever it is, all the series contains strings. All the elements of the series are value mutable and size immutable. You cannot change the size in a series. Mutable means you can change, you can overwrite. Immutable means you cannot overwrite, you cannot change once you have a defined series or the length of the series. You cannot change the lengths, but you can change the elements in the individual location. And data can be of multiple data types, such as n-dimensional array, lists, constants, series, dictionary, etc. And indexes must be unique, hashable, and have the same length as data. And defaults to NumPy arrange n if no index is passed. So if there is no index with your series, then the default index is going to be 0, 1, 2, 3, 4, 5, 6, all the way to the size of the series. If you have 100 elements in the series, from 0 to 99 is going to be the default index. But you can also set an index for your series. Data types of each column, if none is mentioned, will be inferred automatically, the data type. Since we said the type of the data type is identical or homogeneous across the series, then just it will be inferred by simply looking at one of the elements, and then just all the elements are going to be considered as that type. And deep copies data set to false as default, deep copy. Now let's see the first series. Now we are creating a series, PD series. The series function creates a new series. Just this new series will have nothing in it. It's an object, but we can add an element into it, elements into it. The way we add, so creating an empty series. So this is the object. The data type is by default float64. But it doesn't have anything. Creating a series from an n-dimensional array. Now we have one-dimensional array, which remember we use pandas in NumPy. No, NumPy in pandas. Pandas is the upper, NumPy is just the dependency. So NumPy array, we are creating just an inner object, and then just on series, PD series, we are adding it. We are initializing the series one. Initializing the series one using the NumPy array that we created. So this is creating an object, an array, a single dimensional array containing these 5 elements. And the series, we are creating a series by using PD is pandas, NP is NumPy. So if we print this run, and then just you will have this series printed with data type integer, right? Data type integer. And if you remember what we said, the elements are 10, 20, 30, 40. The elements are on this side, on the right side, But the left side are the default indexes. If we don't specify index in the series, as we said earlier here, the index is going to be, the default index is going to be this one. So this was what we were saying. The index is going to be from 0 to the length of the element, the length minus 1 of the elements, 0, 1, 2, 3, 4. So this is a default. But we can have a data with the corresponding index. So just here are indexes A, B, and C. A, B, and C. So this data gets created, and this series will print differently as ABC, ABC, 10, 20, 30. So this is another series where we provided the index for the number. Now, we can print, we can also slice. Retrieving a part of the series using slicing, we can slice the second element to the last element of this array. The reason why I say the last element is because I know that series 1 has got index 4. So the last element is 4, but the last element is not going to be included. And the second element, because I said the second element because index starts from 0, 0, and then 1, then 2, 3. It doesn't include the last element 4. So this is how it is. So this series 1 is this series 1. And this series 1 has got these elements. So we are slicing from the second element to the third to the fourth element excluded. Now, data frames. This is the most important piece of information that you should know, because everything that we are going to do in data science is going to be dependent on your understanding about data frames. Data frames, in short, data frames are like tables of data, having columns and having rows and columns, Data frame is a two-dimensional data structure, The one dimension is the row, the other dimension is the column. So any data that we want to manipulate, process, clean, and then just pass to an algorithm to train a machine learning model should be in the form of data frame. So it's important to understand that. So data frame is going to be composed of series, which is created using Panda, or arrays, which is created using NumPy. So a data frame is a two-dimensional data structure in which data is aligned in a tabular fashion consisting of rows and columns. And a data frame can be created using the following constructor: Pandas, and then data frame, data, index, data type, and copy. So data can be multiple. So this is basically like just we use Pandas. The Pandas library is going to be used for creating a data frame. The Pandas library has got a method called the data frame. The data is our target data, the two-dimensional data, and the index is the columns, the column heads of the table, if you will, and then the data type is the generic type that we want to provide, whether we want to provide the data frame with, if it contains consistent data across. And copy is if we are creating a copy of the data or keeping the data as is. Then the data can be of multiple data types, such as n-dimensional array, list, constants, series, dictionary, etc. And index row and column labels of the data frame default to NP arrange. So the column labels, if we don't provide this index here, then the column labels are going to be defaulted to 0, 0. And the defaults, if no index is passed, no index is passed, and data type of each column, the data type of so the data type is just the type of each column, and creates a deep copy of the data set to false as default. So let's create a data frame. Now this is going to be a tabular format. Now we have the list, and then using this list we are creating a table. as I said, data frame. This is a data frame, which is a table. And running this shows you what type of table you would see here. 0, you see that this is the column label because we didn't provide a column label, and these 0, 1, 3 are the index label. So you can consider this as the Excel rows and columns. On Excel, if you don't provide a column name, Excel by default provides us maybe like underscore column at the top. Whether if you don't provide like just the row names, Excel has got 1, 2, 3, 4, 5, but you can add your own row names or with values. So this 0, 1, 2, 3 is a default value because we didn't provide. But if we provide column labels like this, A, right? Okay. Yeah. So if we provide this as A and B, then you will see, and then C. So unlike the previous issue that we experienced, if I run this, you will see A, B, C will be our values, our indexes. But for C, the first column will have no value. So this is the table. We have this data, and this data is sorry. Okay, so you see A, B, C. A, B, C. No, A, B, C are the column names, and the rows are 1, 2, 2, 4, 8. 1, 2, 2, 4, 8. So in case of C, C is the column name of the second row. The first row doesn't have a C value. So the first row is none. So for C, which means null in other programming language like C sharp. So none means none in C sharp or SQL, also null for SQL. So this is how we create, and then just let's create data frame from a list of dictionaries. So this is data. The index is first and second. So you will see as the column names, and the data is the same data that we have here. Instead of just 0 and 1 here, now you will see first and second because we are providing index. So let's run this and see. We're running this. The data is exactly the same data, this data. And when we were creating this data, the data frame didn't have index here. The data frame just simply had data, but not index. Because of that, the default values were used. In this case, we can use the in the second case, we have this index set. So the first and the second as row identifiers. The indexes are row identifiers, and the labels are the column identifiers. And we can also convert a dictionary of series into a data frame. Now, a dictionary means this is a series and another series, and then 1 and 2 and their corresponding index are A, B, C, and then just if we create these, you will see how it shows up. So ABC, index ABC, but there is D in the second column. This is considered as a column. The second, the column, the first column, 1. It doesn't have D as index. The second column, 2, it has D as index. Where since the second column has index as D, for D, the corresponding value is 4, but for D in the first column, since it stops at C, it is none, right? So that's how you create Pandas data frame. Pandas data frame can be created. So we are simply just talking about simply a 2x2 or like a simplified version of a table. But in reality, this data frame will contain megabyte or gigabyte of data containing thousands of or millions of rows, and thousands of columns. So the data frame, usually like for machine learning, you would need a bigger data size that you have to manipulate. And all this data is going to be maintained and manipulated in memory. The Pandas data frame has got, as you learn more, Pandas data frame has got a problem. The Pandas data frame, since it contains the entire data, it represents the entire data. This entire data hard to fit a virtual, just one machine. There are other machine learning libraries such as Spark data frame. The Spark data frame is designed in such a way that it can be distributed across multiple machines for distributed computing. Pandas data frame, unless it is complemented by other libraries, Python libraries, Pandas data frame as is does not support distributed computing, which is very, very important in machine learning and big data analytics. So just as a note. Now, so as I said earlier, such a data frame can contain millions of rows and thousands of columns. If there is any question, you can write on the chat. Any question? Okay. Okay, no questions. Okay. So data frames, when we are doing data processing, we would be manipulating data, updating data in the data frame, deleting data from the data frame. So different, or adding data into the data frame. So these are the different options or operations that we can have on a data frame. On a data frame, we can add data as columns or rows by merging multiple data frames or by adding new data into the data frame. Or we can delete a column or a row from the data frame. Or we can update data in the data frame. So these are the three different operations. So addition, deletion of columns. So to add, for example, table 3 is, if you remember table 2, we have table 3, we have column 1 and column 2, which is column 1 here and column 2 here. but we are adding, this is as simple as this. Like we are adding a third column just like this. Sorry, a third column just like this by using index 3, or I can use number 3 here. It doesn't matter, number 3. But let's say, let me use my name, and I'm going to use Danny as the index, the column name. And for this column name, I am adding the a new series containing the data as 10, 20, 30, and the index as ABC. Remember, the index is A, B, C, D. So the done column is going to have none at these. So it's executing and it's going to. So 1, 2, then so these are this is the first column, this is the second column, and this is the third column, then. And as I said earlier, since D doesn't exist as index here, or why don't we just add D here, but remove C, and then just instead of D being so you will see 30 is going to be down here, 30 is going to be down here, and C is going to be none or null. Okay. So so this is how we could create. Now we added this column. This column we added, and data frame column. Deleting a data frame is like this. We wanted to delete the first column, which is 1, and now this is going to be deleted, and you will see a 3x2 data frame, a 3x2, no, a 4x2 data frame. A 4x2. So instead of just 1, because we used, this is how we delete this method, del, and then the name of the data frame, and then in a sharp bracket, the name of the column that we wanted to delete. So this is how we would do data manipulation. And again, we can pop the data frame. Data frame columns can be deleted using the pop function as well. All right. So print table 3. Now table 3, 2 was deleted, and then just no, 1 was deleted in the previous one, and 2 is going to be deleted, and then just my named column remained. So but the method that we used here is popping. So just check the difference between del as a delete mechanism and pop as the other mechanism. Let me do. Okay, fine. And now, as we can delete rows, we can also, as we can delete columns, we can also delete rows. So data frame rows can be selected by passing the row label to the log. The log function is for us to grab the location of the row, This is a function. So this So so table 3 loc C means just we are accessing the row. We are accessing the row. Now, row selection can also be done using the row index. The row index. iloc means index loc, index location, index location. So the zeros, like in table 3, we can start. It's a bit slow. Okay, so let me close some applications on my machine so that I don't get affected by memory loss. Okay, I don't need this. Okay. And then now, so here is how we were accessing. Here is how we were accessing the row by using the location, the name of the row, the named index, or the index value too. So we can print this row as print table 3, and then and this value is at C, it is null, right? This row at C is null. To make it clear, let me rerun the code. By the way, in Python, once you modify, especially just in Jupyter, once you modify an object, you cannot get the original one because it is manipulated in memory. If you want to get the object back, then you would have to rerun the step where you created the object. So this table 3 was modified. I'm going to overwrite it with the full data so that I can use. And this creates the first, the original data frame, the original table, and this adds the third column. I'm going to do that, and I will show you what happens down there. So these are the 3. Okay, here I was trying to access row identified by C because I ran it after we manipulated, after we deleted the 2 columns, which is at this point. Then C was only getting 1 column, which is done. The 2 columns are 1 and 2. 1 and 2 were deleted using delete 1, and pop 2 were deleted. But after that, I reran the object and I created the entire table. So my new C, if I run, so you will see now the delete in the manipulation is I passed them, and then just you will see in, sorry, in from executing this, okay, so you will see this. This is going to be what you would see. The name, and then this. This is what you would see, because I created the original data frame, but this one was showing the manipulated or the data frame from which the column was deleted. The two columns were deleted. Now this new one is going to give us, it's going to overwrite this. This is going to be overwritten. Just wait a minute. Okay. Okay, it's coming. Okay, here you go. 1, 2, the name, and the name is C. So the name is C. Look, C was none, but the way it is printed is like from this table. This table, 1, 2, then name. It's inverted, right? It's inverted. So, but the values of C has 3.0, and then 3, and then none for this. And here is what we got printed for us. And the column type, yeah, so 1, 2, then 3, 3, and none. And the name of the row, the name of the row index is C. And again, let's see what this prints. It's not going to be any different, because A, B, C, which means 0, 1, 2. The C's column is going to, the C's row is going to come. The C row values are going to come for us. Okay, so one thing that is going to print now, the same thing, right? The same thing. This was using the index location, and this was using the index name, the location name, the indexed location. And we can import and export data. For example, here I have locally, I have data, sample data.csv. And just I wanted to import this data. This data, let me quickly show you the data. This data has got 0, 1, and this. So this is the data that I have here. And it is indexed with 0 through 9, and the row, the column names are A and B. And then just let's see how it gets loaded. So just to load, read CSV, read comma separated value, because this is a comma separated value. As we saw, this file contains comma separated values, and the extension is a comma separated extension. And just to load, we simply use Panda, the Pandas data frame, the Pandas library, and then Pandas library provides us a method called read underscore CSV, for which you pass the path of the file from where you want to load. This path could be a path on your local environment. This path could be a URL path of any location on the internet. And now let's try to load. And by the way, this dot means the current directory is, if you see, like this introduction to NumPy and data, the folder data are at the same location. It's important to understand this. Same folder structure at the same folder, and from the current folder go to the data. So the current folder is where notebook v2, and then just in that, that's what data means. Wherever the file, wherever the executable is considered as a current, and then from that current. Anyways, so this is going to be loaded. Okay. So loading data is very important. Loading data is very important because we have to get data from somewhere else, from somewhere. That somewhere could be a local location, a local file path, or that location could be a network location or an internet path. So in any case, now this command got executed. We read the CSV file of the name of the CSV, the data frame. This is the data frame name. Most of the time when you load data frame from wherever it is, you call it df, right? You call it as df. So df means a data frame. And let me rerun this again, reloading df instead of CSV. Even if I run CSV, I will get the table CSV, I will get the data, because as I told you earlier, in Jupyter Notebook, once an object is loaded, until you restart your current session, all the object variable names are going to remain there. And any manipulation on those same objects is going to be maintained within that. So CSV, it says the code knows. The code underlines it because I don't see it before in the code hierarchy. But if I run this code, it should give me the data that it contains, although it doesn't exist. The reason why I am getting this data is because when I executed earlier, it cached it locally, and then it will serve me. Any manipulation that I'm going to do on this object is going to be on the cached object. But I replaced this cache, this object, by df that doesn't overwrite. So this is the behavior of a Jupyter notebook, that you, when you run it on a browser, the browser caches the previous execution. If you rename the variable name, it doesn't clean the old variable until you restart the current kernel or the session. So, but to avoid confusion, so this I gave you to tell you that to say that just whenever you load data frame or you initialize data frame, you would use df data frame, and df, the same df. Okay, so the same df is going to have the same type of data, df, because I executed this line, and you will exactly see the same type of data because we loaded the same data 2 times with 2 different variables. The 2 different variables are the dev data frame and the table CSF, another data frame, the original data frame that I used. And the data frame is coming, and it will show us. Taking a little bit. So what I learned, you see, this table and this table are exactly the same. The only difference are the variables name, the variable names that I used to load the data from the same location. So I'm going to delete this and just so use df from this time on. Since I changed table CSF to now df, so I wanted to write. So earlier we were reading a CSV file from a location. Now I'm going to write the data that I loaded into the data frame to a new location, So the purpose of this is basically just you wanted to write data. So the read is to read data from one location. The write is to write the data to maybe another location. Maybe the data that you're writing is a cleaned version of the data, a cleaned version. You may want to clean the data, right? Obviously, for machine learning, you cannot simply just grab a data and pass it to an algorithm. Instead, what you do is you get the data, you clean it, maybe just you simplify it, and you identify the important features that you want to use for your machine learning process. And by then, your data frame is going to be a completely different data frame from the original that you started with, because the original data frame has gone through multiple steps of data cleaning, data pre-processing, feature engineering, identifying the best features. All those steps are going to be applied, which result in changing the original data frame to a totally new data frame. The number of rows is going to change, the number of columns is going to change, the values in the data frame are going to change. As a result of that, you will have a totally different data frame. So that data frame could be saved to a new location. So that's why we need data saving. Reading is for pre-processing, and saving is for saving for further process. And that saving could be for saving of the latest data after manipulating. For example, now I just wanted to delete, let's say I wanted to add a new column, say feature, and is equal to, I have PD dot series series, and let's say the array is and NumPy. I wanted to use the NumPy array. Okay, arrange, they say to, let's start from in I'm going to add okay, arrange. Okay, arrange. They say 5 to 5 plus 10 is 15, 16. Okay, so let me add this. Is processing. Then feature is going to be added as a column here. So this was one of the approaches that we said we can manipulate the data frame. It's taking a while. So one thing that I learned is even my machine is not as the machines that we could get from the cloud. So in our subsequent classes, I might be using the Google Collaborator for our for executing our notebooks. So this is not supposed to. The module name has okay. PD series. Okay. PD series. Okay, let me use this. Yeah, for the next 20 minutes, I'm going to explain the project. And next week, we will discuss about matplot, which is very important, as important as data frames, because anything that we're gonna deal with, yeah, I think my machine is very busy doing the recording, I mean, the presentation as well as like the execution. So that's the reason why it is taking longer. And the new approach that I used today was using, instead of using the Teams, the desktop Teams version, I have been using I've been using the Chrome, the web version of Teams. So it has got its own yeah. Okay. Can you hear me? Just I cannot see your reactions. Okay, I think. Okay, so I added feature here in the data frame. Okay. I added feature here in the data frame, and if I print the data frame back, then just you will see a new column getting added, a new column getting added with these values as column values. Here you go, feature. So we appended this. Now this data, the original data frame that we read was something like this, and we are going to write a new data frame. We are going to replace this new data frame with the corresponding value, and you will see what it looks like. So this is about writing. So data frame def, by adding feature column, we manipulated. So this manipulated data frame, we wanted to write it back. To write it back, we can use instead of let's say latest new data sample data, and then you can write it using this to CSV method. The data frame is the same data frame, but the method that we are going to use is CSV. Data frame is a data frame that contained the manipulated data. So here you go, the latest new sample data. Here it is. We wrote it here, and if you see here, you will see our latest data that we manipulated, that we got. It might take some time. Yeah, it is done writing, and we should see it. Okay, while this is going to load, can you hear me? Okay, so the updated data frame has got the feature column here, and this new value added onto it. The new values added onto the data frame. And let's see. Okay. I see some hand here. Okay. Maybe I'll allow you. Okay, good. I think can someone tell me if you can see what I'm sharing? Tell me if you can see what I'm sharing. Type on the comment. Okay, okay. Yeah, yeah. So from all of you got it. Okay, so you see this screen, right? Okay. So the saving command, yes, I can go back to the saving command. The saving command was like this. So here, the reason why we are reading data is because that's how we get data from wherever it is stored. And the saving command is our way of storing the pre-processed, the cleansed, the transformed data to a location where we can grab it later for our machine learning process. Most of the time, the most common scenario is as soon as we get data, as soon as we load data from where it is stored, we don't basically jump onto pre-processing, transforming, cleaning, and then immediately go to data science processing and data science or machine learning training. So that's not how we are going to do. Instead, what we are going to do is we store it in an interim location, and then from there we will grab the processed data and do the machine learning training. So because of that fact, we need to know how to read data from where it is stored and how to write data into where we want to store. So the way we read data is, yeah, my machine doesn't seem to be collaborating. Okay, I'm going to take some time and stop this execution. I'm going to stop it. But what I'm going to lose is, yeah, I think I have it in my OneDrive. I have it in OneDrive when I shared you. So I can stop here. Oh, the problem. Okay, let's see if that works on Google Collaborator. I'm going to close this. I'm going to close this. And I'm going to share the Google Collaborator and see work from Google Collaborator. Because I remember I shared you this notebook. Okay. Okay, I'm going to pause. Yes. Okay, so let me open Google Collaborator. And here, okay, so this drive in Foundations of Machine Learning notebooks, I have this notebook. So using Google Collaborator, I'm going to use the Google feature, which I think would simplify. So this is a notebook that I was using, and we were okay. Okay, thank you. Yeah, I will share. Okay, share the entire screen, the screen 3. Let me know when you see my screen. I think you should see it. Okay, one answer is enough. Thank you. Okay, good. So we did, let me search for the location. So what did we do? See, to CSV. We were right here. And then just this is how you would basically just save data into CSV. To CSV, and then just you provide the name. But in my case, I have to modify the paths, right? I have to modify the paths. So this, and then just you can also read from Excel, since Excel has got other just a book in an Excel. You can read the entire Excel data, or you can write the Excel data into a certain location. So this is basically reading and writing data from a location into another location. Now, this step is very important. Again, well, I mentioned everything is important. This is a summarized notebook, and I can MATLAB. Matplotlib is the plotting library, which is very important in machine learning. In machine learning, you would use this plotting library, and it is inspired from the MATLAB software and reproduces many of the MATLAB features. In the way you import MATLAB, Matplotlib is using this pyplot and plot. Then just I'm going to start here, connect to hosted runtime, and then just I can run this. So this was the easiest pass. I think just it. So it is initializing the Google Collaborator for me, and then yeah. Okay. Okay, so it is successful. I can see everything is it's green here, and then just I wanted to plot this. So plotting is simple. Look, just a line graph is plotted. We are plotting the list of vertical coordinates of the points plotted, 1, 2, 3, and then plot show, right? Plot 1, 2, 3, 4, 0, and so as you can see, the list of vertical coordinates, and it displays the PLT show is a method too. If you forget this, let's say, let me comment this line, and if I simply just run this line, nothing will show up. Well, you see, because it was already plotted, but without plot PLT show, this graph wouldn't have been shown. Yeah, and so we can specify the values for both axes. Now, just here, the x-axis was implicitly created using the index 0 to n-1, where n is the length of the list. The length of the list was 4. 0 to n-1 means n is 4, n-1 is 0, 3. So the x-axis stops at 3 because 0 is mapped to 1. As you can see, 0 and 1 are mapped. 1 is mapped to 2. As you can see, 1 is mapped to 2. So the index, so this is like a line graph which contains coordinates as follows. Coordinates as follows: 0 and 1, 1 and 2, and it goes on to 3 and 4. And 4. So this graph shows this line. So we just simply plotted a line, and this plotting is very important. I think we are on the hour, and what I'm going to do is I wanted to quickly go over the assignment, but I don't think most of you have that much time. So I will briefly do the assignment and see. I may have to record myself and send you the homework. I mean, not homework, not assignment, but the project. And I will share it to the folder. So the plotting, since it is important, we will spend some time next week, and I will show you some of the key points about the plotting, adding labels, adding title, adding legend, adding markers. All these are very important in saving the plot for later use. Plotting different types. We might want to plot a scatter plot or a histogram or a bar graph, pie chart. All these kinds of graphs are there, and we will summarize. Once we go through these different types of plots, then just we will immediately jump onto the details of machine learning. It is important for us to know these things. Number one, the Python coding. Number two, the visualization, data visualization. Data visualization is possible by using the matplotlib library, which we just started, and even manipulating data is possible by using the libraries like the Pandas, the Pandas data frame. The Pandas library is important. because the Pandas data frame, which is our important construct for machine learning, is in Pandas data frame. And also NumPy is another important library, because it is important to understand how we manipulate libraries. I mean, how we manipulate arrays using NumPy arrays. NumPy, Pandas, and Mathlib, these three are very important. That's the reason why we are spending a good amount of time to deal with these details. And well, just some of you can stay. I am going to anyways make this project explanation as part of the recording, and I created the project document, and the project document has got three parts. Let me collapse all of them, and three parts. The first part is, well, the first one is a title, the machine learning project for addressing a real world problem in an Ethiopian context. So our objective is going to be creating a real world problem in the Ethiopian context. Well, why do we need a project? Because unless we do a hands-on experience using a project, we won't basically remember the topics that we are covering. So the first part is the project detail. The project has got the following details. It has got an overview, objective, a team setup, the project reward, and the project instructions. The project detail here is, in this machine learning project, you will develop a model to address a real world problem in Ethiopia. So the goal is to leverage machine learning techniques to find a solution that can positively impact people's lives in the Ethiopian context. This project will involve several stages: problem identification, data collection, processing, model development, and evaluation, which are outlined in the problem area in the Ethiopian context section. So the problem area is section 3. I will briefly go over that. Second, the objective is this project aims to enhance your understanding of machine learning while fostering a practical approach to solving real-world challenges. So this is the objective. And the team setup, it's important for you to note this step. You can set up a project team with a minimum of 5 and a maximum of 10 team members. And second, the team members are recommended to be from the same campus or the same university. And then details to submit before May 21st, 2023, which is before next coming Sunday. You should be submitting, this is in European calendar, you should be submitting, number 1, the list of team members and the team leader of that team. And number 2, the team's selected area of machine learning development. This can be changed later depending upon availability of data. Since the purpose, the machine learning process comes later, you could change the topic, but after week 5, you won't be able to change. So week 5, week 6 should be the last week that you would be considering. You will be documenting things. And the project reward, with the help of the university coordinators, the project will be evaluated, and the top 3 projects will be rewarded with a token of encouragement. The specific reward details will be discussed with the coordinators and revealed to winners at the end of the project. So everybody will know, but winners will get the reward. And the instruction is here. Again, note the colored text here. This project is required for students taking the machine learning course at their respective universities. If you are taking Introduction to Machine Learning or Foundations of Machine Learning, you are required to work on this project. However, it is an optional yet recommended project for others. I expect all of you to take part in this. Otherwise, the whole thing that we're discussing here is meaningless, nonsense. So I strongly recommend all of you to take part, to partake in this project. So while students taking the Foundations of Machine Learning course get graded for their effort in this project, they will also get considered in the project reward. It's just the reward is for all of you. That's what it means here. The reward is open for all of you. So students taking the Foundations of Machine Learning or Introduction to Machine Learning are required to work on this project and also are eligible for the project reward, not only their grade for the course. And the project will involve the common phases of machine learning lifecycle outlined under the third section. Regarding the potential machine learning usage opportunities, multiple areas. Sorry, the project will involve the common phases of machine learning lifecycle outlined under the machine learning lifecycle. This is section 2 of the document. This section outlines the machine learning lifecycle, and I will come to there. And regarding the potential machine learning usage opportunities, multiple areas are identified and grouped by domain in the Ethiopian context. I put together different domains that you can consider for your machine learning exercise. So they are documented under the problem areas in the Ethiopian context. So this is, they are documented here. And the other point is the project document is expected to detail each phase and the corresponding actions taken by the project team. So the life cycle has got defined phases, and the team is going to be responsible to outline and define and document when submitting. The submission, this is the requirement. And the dataset in Python code should be submitted and are required submitted and are required. Okay, so the dataset in Python code should be submitted and the following are required. One, the dataset should be accessible to run code and retrain the model. If you use any private private dataset, we won't be able to access. For example, I know some of you are members of like just the academic, the medical faculty, and I don't want you to use your patient data from medical faculty if you can, unless you made it unidentifiable, like just you have to anonymize the data. If you anonymize the data and then just make it not associate, make it like just difficult to associate that data to anyone, in any particular person, you can use that data. Otherwise, I don't want you to bring the name of patients, any other details of individuals, which is not ethical and not required. So for that reason, you have to make sure that your data set is doesn't identify anyone and should also be accessible for running the code. And second, the Python code should be should run without errors or issues to train the model. So these are the requirements of the project. And this is the entire requirement. So the next two sections, as we briefly mentioned in some of these in the instruction, are educational sections. Not only their project requirements, but also they are going to be helpful for you to understand the overall machine learning process. The overall machine learning life cycle involves these stages, like the problem identification, data collection. You can go through the details by yourself. I'm not going through that. Data pre-processing, feature engineering, models development, and model evaluation, communication and documentation of reflection and future work. So these are areas that you would need to mainly, like just up to model evaluation. These are the most common data machine learning life cycle. Now, so this is one thing about the life cycle. So you are expected to document this detail for your chosen machine learning project. But the other detail that I have here is going to be helpful for you, especially for those of you who are involved in teaching, who are going to be involved in teaching machine learning or data science projects. You can use any of these project details. Like these are scenarios from the Ethiopian context. In the Ethiopian context, machine learning offers various opportunities to address a specific challenge and contribute to the country's development. Here are some potential machine learning usage opportunities in Ethiopia. For example, in agriculture, food security, and forest management, you can use machine learning for optimizing crop yield production or crop disease detection and management, livestock management and disease prevention, drought prediction and food security, land use and forest monitoring. So these are under agriculture. And in relation to environmental management, you can use for environmental conservation or air quality monitoring, natural disaster response and management. So these are the three in the area of environmental management. In healthcare, you can use machine learning for early disease diagnosis or disease surveillance. So these are the areas that you could use in healthcare. In financial services, you can use machine learning for fraud detection, financial inclusion in mobile banking. So these are the areas. Another area is water resource management. I know we have like members of this group from Arba Minch University, where people may be interested in this water resource management related machine learning application, water availability prediction, water sanitation and access, water resource planning and allocation. So these are some of the areas that you can apply, and the respective details you can go through. And again, in energy management, now we have the Millennium Dam. To complement the Millennium Dam, we may be interested to use renewable energy. We may have some data, so predict the renewable energy or renewable energy planning or sustainable energy planning. So these are the different areas that you can use machine learning in relation to energy management. The other area is transportation and urban planning. In transportation, we can use machine learning for traffic prediction or traffic accident prediction. So traffic prediction is something to optimize the traffic flow. Traffic accident prediction is to maximize the safety of passengers, and traffic management for urban areas is again another area where you can utilize different how to basically just reduce traffic congestion. And urban planning and housing, I combined the urban planning with transportation because they are related to urban. As we know, in Addis Ababa, in most big cities, we have a housing problem. How can we utilize machine learning for the urban planning and housing? So most of these areas are thought in relation to just the different students or participants of this training having background from these different areas. You can pick any of these areas for your purpose, but ensure that your team is not more than 10 people and not less than 5. So I recommend just a greater team. I'm just a good number of team members, so that you know, just you can bring ideas together, discuss and how you can do things. It's only when you practically apply what you're learning that you will forever remember what you learned here and utilize it in your real life scenario. When it comes to customer relationship management in marketing, you can use machine learning for customer sentiment analysis, how they feel about products and services, and what kind of feedback that they provide. And for e-commerce and market analysis, you could use, again, recommendation related systems. And in education, we can apply machine learning in education. Language processing and translation, because Ethiopia has got diverse, is a country which is linguistically diverse. So we need support for the different languages that are spoken in Ethiopia from different perspectives. So from that perspective, I know in Addis Ababa University, there have been so many projects on machine learning related stuff for language processing and translation. So you can expand that and make your own case. And finally, cultural heritage preservation. In different parts of the country, Ethiopia has a rich cultural heritage, so we could utilize this. So this is a project detail that I put together, and then ensure that your project, your work is original, not copy from anybody in the world, because I have a way to check plagiarism. And our ultimate objective is to, just put our learning into practice, just understand more of what we're learning and apply it to solve a real world problem in our own country perspective. One thing that I want to advise you is machine learning, just because I get this feedback from so many people. Oh, where can we get data from for our machine learning process? So find a way, just be creative to get data. Machine learning is not like የቅንጦት እንትን አይደለም machine learning. It's just a way to solve a problem. It's not a luxury for Ethiopia. Unless we start somewhere, we won't be able to do anything. So you will be responsible to do this, or just make yourself responsible to do this, so that you can help yourself and your country and your fellow countrymen and women, and improve their life. After all, it is the right venue to discuss about projects of this type, because you all are masters and PhD holders. So unless we start these kind of issues being discussed, unless we stop this kind of problem-solving approach as a luxury, we won't move the development needle. So just this is the reason why I put together this project and sharing with you. With university coordinators, as I pointed out in the outline, we will discuss more and see how we can set up the reward process, and then the first the evaluation process, and then finally the reward. So any question? Yes, I will share. Maybe I will. So this document, yeah, I will share it to you. I will before I forget. Let me put it in the OneDrive, right? Before I forget. Yeah, I'm going to put that. If there is any question, ask. Otherwise, I'm going to stop the recording.